Thanks everybody for coming. Name of my talk is Demonolithing the Monolith, Bullocks. Now, most organizations, both business shops and software shops, have that ancient application. It's been around forever. It supports most of the business. It's been around for a long time, and it's gone through many technology changes, business changes, whatever the case is. And at some point in time, it becomes just too much to maintain. The time to actually add new features goes up and up and up. The number of bugs you see, especially in production, goes up and up and up. And you got to figure out what to do with it. And the answer these days is, we're going to demonolith it. That's what we're going to do. And I actually thought that this was possible. I really believed that you could do this. You would go into the monolith and you'd pull out pieces at a time, and here's a microservice there, and the front end there, whatever the case is. But the more I talk about it, and the more I talk with friends and peers, I don't think it's going to happen. There was an application architect I used to work with, and he really thought that, over time, the monolith would become just a shell, and it would just kind of blow away into the wind, and everything would be done. And you'd have this nice new architecture. And again, today we look at microservices, we look at micro front ends, API first, probably NoSQL databases, all those types of things. But then we started talking about some of the problems. It's a unified user interface. It's a big mess. Everything's together. The APIs are inconsistent, don't really represent the business at times, are incomplete or are duplicative. You've got a lot of tech debt in there because it's just accumulated. We all know the tech debt, plenty of conversations here. It's got internal messaging, so there's no way for an external consumer or producer to participate. So once you started talking through these problems, it became apparent that this isn't going to happen. This is never going to happen. And in fact, I practiced a speech with a friend in Glasgow, and he's like, funny you should talk about this, because 18 months ago, his now former company was like, yeah, we're going to demonolith. And 18 months afterwards, it was like, yeah, it's never going to happen. So, about me. Obviously, my accent indicates I'm from America. I live in Minnesota. That's the green state, in case you don't know your states of the union. Minnesota is lovely during the summer, miserable winters sometimes. Last winter, we had 230 centimeters of snow. That wasn't the most in the state. I work at a company called DataSite, and they do software as a service for mergers and acquisitions, virtual data rooms, and I've been there for 16, 17 months. Now, my wife and I love to travel. 2022 was a great year for revenge travel, and we went to London, Scotland, Iceland, Canada, Japan, New York City, all sorts of places. And that's our COVID kitty on the left. He's reviewing my architectural guardrails and guidelines I was working at. He looked at it for a long time and didn't give me any feedback. He also has heard this speech more than anyone has ever heard it. Again, no feedback. And just as an aside, I really like old maps. The map on the left, between the P and the A, 459, that's where I live. It's an 1892 real estate map. My house was built in 1886, which for Minnesota is ancient. And for London, it's new housing. In the middle are some street maps that I found in an antique store in Wisconsin, which is a neighboring state for those of you who aren't aware. And what's most interesting is in the middle on the right there, it says Royal Agricultural Hall. That's where we're at today. So this started off as a Royal Agricultural Hall. The first event was a bike race. And it's been a parcel sorting unit for the post office, and now we're here today. Gotta have the disclaimers. These are my views, not necessarily that of my employer, except my employer went through a lot of the things I'm going to talk about and before I got there. And again, they're based on my experiences, not yours. There's a million ways to do a Hello World program, all of them right, all of them wrong. So you're not going to agree with me 100%, and that's fine. We'll agree to disagree. Really what I'm trying to do overall is just give you some ideas, things to think about, things you might run into if, in fact, you're told, hey, we're going to demonolith. You may take action on it, you may not. It's not my problem. So in a nutshell, if you're asking for that preliminary advice, what should I do if I'm asked to demonolith? And my answer is don't. I think it's a lost opportunity. I think it's never going to get completed. And at the end of the day, it's just not worth the effort. It's not what leaders want to hear. Even as engineers, I don't know if we want to hear it, but I just have too many examples of where friends, colleagues, and others have said, yeah, we just can't do it. High-level agenda, we're going to talk what kind of makes your application monolithic. We're going to talk about some of the things that you'll find as you dig into the monolith and try and see what you're going to actually be able to pull out, if anything. Then we'll talk about how to do it, because of course leadership loves buzzwords. They may be technical, they may be not. But they love buzzwords. They hear demonolithing, they're going to jump all over it, and they might say, you're going to demonolith. And then as time permits, we'll wrap up, we'll have Q&A, whatever the case is. So I have a friend who's a CTO at a company, and we had lunch about 15, 16 months ago. He said, oh no, after 10 years, we're almost done demonolithing our business critical app. At what point in 10 years does that actually become a rewrite? At what point in 10 years were you not able to present new functionality that customers were asking for? At what point in time did you actually have to go add that new functionality both to the existing monolith and whatever you demonolith? What happened in 10 years with security and technology? This last time we had lunch, he's like, yeah, it was probably more of a rewrite, but I think he sold it to his leadership by saying, oh, we're demonolithing. Took him 10 years. There is a success story. It's something we use every day, complain about every day, we earn our living with, and it's Java. I would say that Jigsaw, the modularization of Java, was in fact a demonolith because they touched everything, right? They touched the source tree, they touched the runtime images, they touched the build process. I don't even know everything they did. But it took 12 years. You know, it started in June 2005 with the JSR. It completed in September 2017 with Java 9. It went from Java 7 to Java 8 to Java 9. They stopped at a point where security issues made them actually focus on the existing. And they did a really good job because for the most part, we weren't impacted. But most of us don't work with organizations that have the patience to wait 12 years to get this done. Most of us work for organizations that after a year or two, it's like, show me the money. And we're like, well, we're just doing this. And to the benefit of the Java team, they push through, and Oracle has the resources, but most organizations can't put up with that length of time. So let's talk about what may make your application a monolith. And we're going to talk mainly about web apps, because that's mostly what we're doing. We're front end, we're back end, we're full stack engineers, we're dealing with data, we're DevOps, most of us are dealing with web apps these days. Not everybody, and I do have examples that are non-web, but we'll focus on web at this point. But we keep having conversations about why is this so hard? And it's really so hard because of the non-functional requirements. I believe that anybody can implement a feature. Anybody can implement a feature. It's engineers who present solutions that have non-functional requirements built in, and often the monolith doesn't have them, or they don't have them in the depth that they need to. And there's got to be a better way. The monolith is not necessarily the way to go. So there's some commonalities on a monolith. I think some of them you'll see, some of them you'll disagree with, but most of them come across as legacy apps. They feel old, they perform slow, the user interface doesn't look like anything you're used to, the use case, the workflows through the screens doesn't look good. Not every app wants to become a monolith. That's not their intent. But over time, it didn't age well. And you've got something that you can't use the term legacy properly because the people who are working on it will be insulted. You got to say it's the current, it's the existing, it's the one that Mo and Myra built, whatever the case is. But at the end of the day, you know that it's not where you want to be for your business. It's usually large. Any way you look at it, a monolith is large. It's got a large code base, it's got a large data model, it's got a large deployment process, build process, it's got a long time for any critical fix that you're trying to put into place. It's got a long time for outage windows when you have to deploy. Every way you look at it, it's large. And it's usually single. It's not that it's a large code base, it's often a single code base. It's not that it's a large data model, it's a single data schema with 300, 400, 500 tables in it. It's not a large build process, there's one way to build, you build it all. Everything, any way you look at it, it's single, and again, that singleness makes it really difficult to pull out strings because everything is so interconnected after a length of time. It's usually very complex. Not every large code-based complicated application is complex that is a monolith. I said that poorly, but the problem with a complex app is you bring in new resources. They could already be in the organization. They might be coming from the outside world. And it might be months before they can actually contribute because there's so much there to learn. And in a monolith, so much bad stuff to learn, right? There's different programming styles that were used at different parts of the application. There is a lot of inconsistencies. There's unnecessary abstractions. You name it. There's a lot of things in there that aren't really necessary, but just naturally evolved over time. And that level of complexity means anytime you bring somebody in, you're going to run into problems. It's going to take a new person. I've seen upwards of 6 months before they could actually contribute. Now, if you've got an enterprise application like Oracle Financials, which is, as I understand it, huge, very well written, very complex, and it takes people a year to really learn what they're doing. Monoliths are just there because it's bad. Everything is bad about it. It's usually fickle, both from an engineering standpoint and a deployment standpoint. From an engineering standpoint, you join the team, you try and find instructions how to set everything up so you can actually do development. You go find Confluence documents that are out of date. Ultimately, you find that one person who's been around for a long time, and she comes over to your desk, does some magical stuff on the keyboard, and she says, don't ask, just go with the flow. Now, from a deployment standpoint, there's usually one way to deploy, and if you don't follow the steps to a T, it's going to fail and you're going to start over and increase that outage window. And even once you get it running, often there are just little tricks, tweak this here, tweak that there. Few people know about it, unexplainable, but it's very fickle. OMD, orchestral maneuvers in the dark, which was an English electronic band. I think they actually still exist, from the 1980s mainly. It's also the things as engineers we do under the sheets that we don't really want anybody to know about in the depths of night, just to keep things working. Could be something simple. We're going to turn off a foreign key referential integrity because the data quality is bad. Could be we're using an open source library that's no longer supported. We don't really have the time or the knowledge or whatever to migrate to a supported version, so we'll fork the code out of GitHub, make our own version, maintain it to the best of our ability. Could be that we've got security through obscurity, magical code, authentication, backdoors, what have you, that we know we need, but we're not going to tell our security team because they're going to freak. Anything that you might do just to keep things working, and you're probably embarrassed about, but you've got no choice. My friend calls this the infinite blast radius. You try and make a really tight change, it's very isolated over here, and something way on the other side of the app blows up, and it usually blows up in production. And you can't explain why, but inevitably, everything is so coupled together that a small, minute change suddenly blows up in your face. It's usually inconsistent. Now, from an engineering standpoint, we've already talked about, the programming patterns that are used. They could use the same technology, or they could use different technologies to achieve the same things in different part of the apps. But it also can be from the user interface, which is really disruptive to the user. I worked for a medical software company, and what do you use for the term of the person that you're representing in the software? Is it a patient? Is it a resident, like in a nursing home or a senior community? Is it a convalescent in a skilled nursing facility? Is it an inmate? I don't know, but if you use all of these terms, and there's other UI inconsistencies as well, as a user goes from space to space in the application, she's got to make a lot of context switching. It's really disruptive to her. It's very obvious that this thing has been cobbled together. And finally, it's just downright scary. One place I worked, Sonar stopped working because a single method in one class could no longer be instrumented. And that was because the method was 3,200 lines long. It was over 64K in bytecode. Sonar could no longer look at it. So I go to Tony, who isn't the original person who created it, but has maintained it for years. And I said, we got to start breaking it apart. First off, you can't even read the code. I mean, it's some of the tech debt stuff that we talked about if you were here at 9 o'clock in the gallery. He's shaking. Because he's like, there's no documented business requirements. There's no test to say if we make a change that I haven't broken anything. He doesn't want to touch it. He just wants to go in, make a little change, get out. And at the end of the day, this code, if he gets hit by a bus, we're doomed. He's saying, well, it's billing. If we can't bill, we're doomed. These are the things where you look at it, you're like, I got to get another job. Typical life cycle of a monolith, in my opinion, first version, it's small, it's concise, it's clean, it's understandable. You can explain it to others. People can come on board very easily and on board, but it's usually not enough to do it. So you've got the next releases. More functionality is added. There's a little fraying around the edges. We've got different colored cables and what have you. That's great. Still explainable. Most of the tests are still valid. Most of the time you can explain what's happening. The functionality is actually cohesive. Great. And then over time, the wheels fall off, and you end up with that over there. To me, that's where you would just start over. Because it's not just the cables that might be the problem. What about the device configurations? Those are probably just as a mess as anything else. I'm going to say, give me some new devices. Let me start from scratch. That's going to be cheaper, faster, more complete, less error prone than trying to go wire by wire on that thing. So high level, there were some chuckles. I'm assuming people saw things that they recognized. Let's talk about a little more in depth what you might run into as you get into it. Now, I had a former boss, and this was his line: design first, code to design. Means something totally different than when he said it. Back then, Ivory Tower enterprise architects, you did UML modeling, case diagrams, class models, sequence diagrams, whatever. You had formal data modeling. Now you have a more collaborative architecture where the architects might have guardrails and guidelines. You empower the team to do a lot of things on their own. They own everything from inception to deprecation. But it's the same thing. Decide how you're going to do it, and do it until you run into a problem that's unavoidable. Monoliths were never designed for a modern cloud architect. It's like taking a square peg and trying to stick it into the round hole. What do? You start shaving around the edges. It no longer represents what it was doing. It wasn't designed for that. And so trying to demonolith, in my mind, is attempting to do that. A lot of monoliths that I've seen are single tenant. And single tenant are easy to understand, easy to implement, easy to secure, easy to document, easy to deploy, but they're expensive. Whether you're deploying in the cloud or in your data center, you usually have to deploy that as the max hardware, the max infrastructure that you're ever going to need. Because at some point in time, there's going to be a load, it might be once a week, once a month, once a quarter, that you need that max infrastructure. So it's the most expensive that you can implement. Now, if you start looking at multi-tenancy, which is where, in my mind, you want to go, you're going to save a lot of money. This is a Danish dormitory design. And you can see lots of things that are shared and some private areas. So shared kitchen, shared dining room, shared study, shared terrace. It doesn't show shared heating, ventilation, air conditioning, or shared electricity, or shared networking. Those are all shared by all the tenants. Now, they still have their own bedrooms, and they probably have their own bathrooms, so I don't see it on there. But the more you can share among everybody, the cheaper it's going to be. Now, something like this, where your monolith is deployed, one per customer. Customer X has their own instance, customer monolith X with database X, Y, Z, Z, da, 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 da. Looks great. You know, it's not too hard. The databases might be shared on a database server, or you might provision individual databases in the cloud. But, you know, by and large, their data is segregated from everybody else. So I had an application architect who said, OK, we're going to take out our first microservice. And I said, are we going to redesign it how we would, like multi-tenant? No, no, no. We're just going to take it out as it is, whatever the APIs are, and we're just going to do it like that. OK. 4 microservices doesn't look too bad. What if you have 5,000 customers and 10 microservices? Now you're deploying, maintaining, supporting, 50,000 instances of that service, or of those services. And the application architect was like, yeah, that's fine. We'll keep going forward. We'll deal with the single tenant later. We'll deal with the multi-tenant later. And they were going to go down this route until the cloud ops guys spoke up and said, if you do this, you will bankrupt the company. That's your choice, but I'm just saying, that killed it. I called it domain discipline. You might call it modeling. But when you start an application early on, you're able to define those domains pretty cleanly. And you're able to define the boundaries and what are the responsibilities and what the data is and how you interact with the other domains. And you've got a clear understanding of where everything lies. Now, early on, that's easy to do. Over time, it becomes more difficult. The product manager moved on. The engineers moved on. Or you really ramped up because suddenly I have to add a lot of functionality, and you onboarded dozens, hundreds, who knows how many engineers, and suddenly that knowledge is no longer passed, documented on, whatever. And over time, your domains become a little bit muddled. So let's take an example, a system for managing tech conferences, like the DevOps application. And I just made up some domains. But typically, what happens is people submit ideas of things to speak on. People review them. The track leads decide which sessions to take. Submissions become a session. They're assigned a schedule, a time, a room. People attend. I'm actually all for this session, because I'm standing in front of you presenting something that I submitted. I was also a reviewer, and I've been attending other sessions. Great. Pretty straightforward. Now, let's say that the conference has decided they're going to be pet-friendly. They're going to allow you to bring your pets to the conference. I'm assuming dogs, not llamas, though my wife and I did see somebody walking his ferret on the street of London. I'm not kidding. So we'll add a new domain. Sounds simple, right? It's got microservices, probably one microservice, maybe more, who knows what. But you've got to keep information about your pet, the name, the breed, the type, is it healthy, what licenses do you need, whatever the case is. Unfortunately, the conference announced this before we actually talked to the engineers to figure out how big a deal it was. It's a week or two before the conference. It doesn't sound like a big deal, but the engineers are like, we've got this list of things, so how can we simplify this? Well, we'll combine person and pets into a singular person, multiple pets, which is wrong, forget that. But we'll just kind of merge those two together, and we'll fudge with the UI and the APIs and things like that. Inevitably, you're going to get a pet who's presenting a session, or a human who owns another human. Slavery is not encouraged. But it's time to market. And what do? You hack this in. And these types of things is what makes it difficult to demonolith, because, okay, I'm going to demonolith this thing, assuming it was a monolith, which the DevOps app isn't. But how do I pull out a pet without diving into what the person domain is? And it just gets messy. Let's talk about data. Again, very simple, very incomplete relational data model for a tech conference. Same concepts that we just had. Reviews, submissions, people, schedules, great. We've decided to pull out our first microservice, and it's going to be about reviewing some of the submissions. Great. And that'll make its own microservice with its own storage. Maybe we're moving from relational to NoSQL. But what happens to your relational model? Now I've got a big hole in the middle. What happens to that dashboard, which was a single SQL statement, multi-table join, that gave you everything in one call? Well, I can't do it anymore. Now I've got to pull some of the information. I've got to make a call or two to a microservice, assemble it back before I give it to the front end. And this is only 8, however many tables are there. What happens in a, literally, I've seen 500 table models? How do you pull out here, pull out there? What do you do about those assumptions you made about transactions? Oh, I have one big transaction. I'll update this, delete this, da-da-da. Well, no, I've got submissions now in a separate microservice. Without, we're not doing SOAP transactions, we're probably doing REST. So this is possible. I mean, my company has a microservice-based app, and we just keep making calls to the various microservices and assemble, but it's a different paradigm. You've got to think differently about it, and you've got to make sure you don't break what's already there. I think this is a real challenge because, again, you're going to get big holes, and you could do things like stash the data locally just to help you, but then who's the source of truth, things like that. Now, the deployment models is going to be more for software as a service shops, where you have sold your software, but in the past you sold an on-prem version. The problem with selling an on-prem version is those on-prem people might not want to be in the cloud. There are still people in 2023 who don't believe in the cloud. There are companies who have issues with compliance. It could be government compliance, GDPR in Europe, FedRAMP, PHI, PII in the States. It could be that they've got industry compliance issues that they need to deal with. They might have a completely paranoid security team that doesn't want anything that's not in their hand. They're control freaks. They might also have just, and there's something else, and I don't remember what I was going to say. But regardless is, you've got deployment model issues because I've got this monolith. I sell it. It's on-prem in somebody's data center or in their managed data center, whatever the case is. What are the choices? And I'm not going to go into the details here. It's just too long. But I only come up with 6 choices, and they all suck. And if I'm a leader trying to say, well, we're no longer going to support the on-prem version, well, guess what? They pay a lot of money. You're not going to abandon them. Okay, so we'll do both on-prem and in the cloud. Well, is that two code bases? Is that 2 deployment models? It's really difficult if you're on-prem selling software. How do you support those people long-term? Every app known to man has technical shortcomings, goes without saying. If you can't see it, you're not looking. Monoliths tend to have a lot more of them, and that just makes the problem all the worse. We all have frameworks. They could be niche, they could be out of favor, they could be custom, which I think is probably your worst scenario. I imagine you're doing an interview, and the candidate asks you, Mr. Sosna, what is your framework that you use for developing microservices? And I say, Flubber. And she's like, what's Flubber? Well, V1 was called Butter. Joanne built it. It was great, really smooth, showed us how to do microservices, not production ready. So we made a V2. We called that blubber because we had to add so much onto it, but it ended up being very manual, lots of templated code, all sorts of problems with it where we could inject errors, especially security. And so we had a V3 where we added all sorts of automation, of course, I'm dropping the word. We added all sorts of tooling. Let's just leave it at that. And the tooling made it really usable, and that's what our version is today. And at that point, your candidate is going to say, thank you very much, and you're never going to hear from her again. I hesitate to ask, nobody has to embarrass themselves, but how many of you are aware of applications which store their credentials in their transactional database? Okay. This says Stone 1990s. You don't do that anymore. There is a reason that we have identity providers, because we delegate authentication to them. They figure it out. They tell us, yes, that's Scott on there. We can trust him. Most monoliths, many monoliths are still doing self-authentication, and they don't have OAuth 2, OIDC, SAML, single sign-on, and all of that stuff. And that becomes much more difficult to deal with once you start dealing with microservices and how you get the security from service call to service call. And again, we all know that people are still doing this, and I will say that's so 1990s. Business logic, where does it exist? It's in the back end, and the front end, and database triggers, and your rule engine, and config files. And now I'm going to pull out a microservice, and there's my 6th place, or another front end, and there's the 7th place. The more places you have that business logic living, the more hassle any change in logic is going to require. Stateful isn't quite the problem it used to be. I think we've learned our lesson from EJB2 session stateless beans. But at the end of the day, there are still places where people are doing stateful application development. Could be on the front end, where your front end goes from one screen to another, and they just pass along the data that they need, again, making it very difficult to pull it out. It could be that on the back end, you are using something where it's like, OK, I'm going to start a transaction on this call, commit at the end. What happens to everybody else who has been trying to either access that data, use the data, manipulate the data, whatever the case is? It doesn't scale. We know it doesn't scale. It's a paradigm shift to go stateless. We're getting there. The resources not being enough for you to do anything with. I've seen places where they use VMs on the cloud for their database servers, and they max it out. Biggest VM, biggest disk, fastest disk, and they still match out the IOPS. Database pauses because you've used too many IOPS in this last second, or whatever the case is. Could also be memory. When I designed the API, there was only 300 or 400 of these objects, so no pagination. I just pull it back. Now the 300 or 400 objects is 30,000, 40,000, 300,000. All of that is memory on the database, memory in your back-end service that has to assemble something and then goes to the front end. I think this actually becomes worse when you demonolith, because now you're making calls out to a service that you have to bring data in and you've got to reassemble. If you don't have enough resources to do the job now, I think it gets worse trying to demonolith. Test coverage, inconsistent, incorrect, non-existent. How do we know when we demonolith something that it works as the monolith expected, if in fact we can't prove that the monolith is functioning the way it's expected? Do I go and write all my unit tests and my integration tests for the monolith in preparation to demonolith? That seems like a really waste of time and effort, and something we'd all be mad at having to do. But if the test coverage isn't there, it's going to be really difficult to know what to do. I'm not going to go deep into tech debt. We know it all exists. We know it's ignored for years on years. There's many reasons why. What happens if some of the tech debt actually has to be resolved before you start pulling out the monolith? It could be security concerns. It could be mismatched APIs from a third party where their V2 doesn't work with their V3. Tech debt goes without saying. And then the skeletons in the closet. You have no idea how that got there. You have no idea how it works. You have no idea what the implications are if you disconnect something. And yet somebody's got to figure that out before you demonolith, because it's there. Whether you like it or not, it's there. It's embarrassing. Fortunately, the person who put it in is probably long gone, which is almost worse. No documentation. This gentleman wrote postfix email server. I think we would agree that every time we add new functionality, there's more code to support. That's great. Usually it's geometric. On a monolith, I think it approaches logarithmic and log n, whatever the case is, because any little change, we talked about the coupling, you make a change here, and suddenly there's changes here and here and here. The bugs go up. Now you start demonolithing, and at some point you're supporting what's in the monolith, what's in the D-monolith because you haven't made a transaction, you're probably going n log n to n squared. I mean, it just goes off the charts with that monolith because the code is so bad to begin with, and now we're adding additional complexities. This isn't necessarily just about demonolithing. This is any organization who really hasn't embraced some of the new things that we're talking about at the conference, right? Cloud-based architectures, microservice, API first, things like that. It's going to change the organization, mostly in engineering, but not exclusively. As you assume, the technologies could change. We were infrastructure as a service. We're going to move to platform as a service. We were a relational database. Now we're NoSQL. We probably have to do events of some sort. We need new ways of observing what's happening. It's no longer a single log file you're dealing with. The technology stuff is going to change. Your design paradigms are going to change. API is a first-class citizen. A lot of people don't get that yet. You're probably going to go a reactive UI. You're not going to have an HTML form that submits a whole bunch of data, validates on the back end, and sends you the results. Your design paradigms are going to change, so your engineers need to change how they approach things. Your processes are going to change. You may not be in the pull request, for example. You might need to start doing pull requests. Infrastructure as code is huge. I will tell data sites infrastructure as code. We usually have 2 clusters running at all times, a hot and a warm. If we want to build another cluster because we think one is flaky, they press a button 15 to 20 minutes later, we have a complete new cluster. And that's provisioning from, we use Azure or Azure. I never get that right. But that's huge, right? And no more of these manual deployments. And then the skills you need. Assuming we have already figured out there's technical skills that are different. But I also think product is different. I think product has to think about things differently. I think that the security team, you're not just securing a single app, you're securing many, many microservices, front ends, who knows what, integration points. You've got compliance, who now has to document everything. If I'm doing GDPR, what is necessary to ensure that data at rest is encrypted, and I've documented it for this MongoDB. So your organization is going to change. If and your organization might not be able to get the skill sets, right? You might not be able to hire. You might have people internally that just aren't going to make the transition. You need to be prepared for that change. So we've talked about identity. Let's talk about approach. But first off, I'm going to start with a non-technical example of a monolith. Palace of Westminster, built in 1840 after the 1834 tally stick fire, damaged during World War II, parts of it rebuilt then, but since really no major gutting to fix things. Sure, they've added female bathrooms because there's more female MPs, great. They've added cabling for video and telephone and networks and probably new electricity, but by and large, big chunks of it are the same as it's always been. During one of the Brexit debates, they had to adjourn because water started streaming in from the ceiling. So they've been worried about this for a long time. They've been trying to figure out what to do. They've got 3 possible solutions. One is the Commons stays, everybody stays, House of Lords, House of Commons, and everybody works around it. 46 to 76 years. To me, that's infinity. We'll all be dead. $22 billion. Now, there's something they call a partial decant. House of Lords moves out. House of Commons moves to the House of Lords. They work on the House of Commons. House of Commons get back done. They move the Commons MPs back. House of Lords stay out while they do the House of Lords. From a technology standpoint, I think that's where you take your monolith and you integrate some third-party app to do subscription management or patient management, and you try and figure out how to do it. And it's not a clean match. Your business logic doesn't match theirs. It's difficult, but a partial decant, still 43 years. Don't save a bunch of money if you think that 2.5 billion isn't that much. Or they can leave totally. 28 years. Okay, you can see the end of day there. 13 billion, almost half less. The issue they have with that is that there are generations of MPs who will never serve in the seat of the British government. Now, I believe they've selected the full decant, but they keep changing their mind. Nobody's happy with it. None of these solutions work well. And I think these are some of the things you have to consider when you're demonolithing. 1993, I had an unguided tour of Parliament. They don't do that anymore. I just got to walk around and follow this route that they gave us. Betty Boothroyd, who was Speaker of the Commons at the time, walked right by me. So if you need to do this, I think there's 4 stages that you need to kind of go through: investigate, design, socialize, and negotiate. When you're investigating, you really need to dig back into the application. You might have been there at the beginning and not been close to it for a while. You might have dabbled in it bit at a time, but you're not aware of that toilet, the washing machine on top of the toilet, right? So you need to dig in and understand what's the technology, state of technology inside of it. What is the business features that are or are not implemented? What's it costing us to support it? Could be from an infrastructure, running it on whether it's dedicated hardware or VMs in the cloud. You want to dig deep to really understand the form and function currently in that application, because you need that confidence when you go and start trying to design a solution, design possible approaches to getting a solution. Problem number 1, there are multiple problem owners that you're going to have to deal with, every one of them having a different perspective of what's important. You're going to have to agree on what is going to measure success. It could be, quicker time to market. It could be reduced infrastructure costs. It could be code maintainability. It could be, future features that we need. There's any number of ways to do it, but you need to come up with what's important and come up with multiple approaches that you can sell to people. Now, you need at least 3 approaches. If you have only 2 approaches, what's going to happen is anybody looking at it is going to say, one is right, one is wrong, I'm going to try and figure out which it is. And if you give them 3, they actually give it an honest look at it. So you need to come up with at least 3 possible approaches to how you might demonolith your monolith. I know most of us are engineers here. I'm sorry to say, whatever you come up with needs to have a business justification, not an engineering justification. We can't do engineering for engineering's sake. We need to do it for the business who are paying us. So if you do it right, you will get some engineering joy out of it, but the solutions themselves need to be mostly presented as a business reality, not an engineering reality. So you come up with your choices, and you try and come up with what might be ways of doing it. Now I need to socialize it. Well before I start meeting with leaders. In fact, I might actually start socializing things as I come up with partial solutions, because some of them might be so traumatic that you just need to throw up some trial balloons and see who shoots spit wads at it. But you need to know who are the decision makers, who are the power brokers, and you're going to need to go through these things a few times, because humans don't accept change really well. And if you're the human who's been working on that monolith for the last 5, 10, 15 years, you don't want to hear that your baby's going away. So you're going to have to start telling people what you're trying to do, how you're trying to achieve it. You need to make sure they have some understanding of how you're going to do it. Great. They're probably going to give you some feedback, some of it completely justified, and you're going to say, I need to go back and tweak my solutions a little bit. When you're an architect, they always say that the best decisions are ones that are decided before you actually get everybody in the room, because you've gone around everybody, you've gotten everybody on the same page, you get everybody to understand the problem. Great. Hopefully you can do that here, because you're going to need weeks, months, whatever it is, to get people to really understand what you're trying to do. Now's the fun time. You get to negotiate with your leadership. You get to tell them that you're actually proposing these solutions that are not cheap, right? Anything you come up with, put numbers on it, they're going to be wrong. And you're going to present these things, and you have to be prepared for being shot down all sorts of different ways. None of your proposals are going to come through unscathed. Every one of them is going to have a change of some sort. And they're going to throw things at you. They might want to do a technical deep dive. They might throw organizational change that's coming up that you weren't aware of. There might be a new business opportunity that nobody was talking about. You're going to have to tap dance, because there's going to be new things thrown at you. But hopefully what you're doing is getting your leadership to make a decision. The problem with leadership is they're risk adverse. They want an evolutionary change. And likely everything you're proposing is revolutionary. What's the problem with evolutionary change? Well, that's what got you to the monolith in the first place. Keep making little short-term decisions and making progress until you get to the monolith. Somehow, you need to convince leadership, no, we can't just keep doing that, because we'll be back where we started. And that's going to be a challenge, because, again, most leaders are sitting there thinking, what am I going to do so I don't lose my bonus at the end of the year? And a real risky thing of starting over is one way that they can see it. So let's say some decision has been made. Let's say that you look at what is there, And you may agree, it's like, okay, this might be possible. You got to be realistic. Because at the end of the day, your name is probably on it. And do you trust the organization to actually take it to fruition, to actually commit the resources necessary, commit the effort necessary to actually do whatever you're trying to propose? Do you know your leaders too well to know that this isn't going to happen because they say one thing and do another? There is a company in Minnesota, and they had a Fox Pro app that ran their complete business for 20, 25 years. And they finally decided, time to get out of Fox Pro. I'm actually not sure if it was a demonolithing or a replacement effort, but they hired a new architect. They were going to do new technology, and the architect said, oh yeah, we can do this in 18 months. And they brought in Agile. Oh, that's going to solve all our woes. We've never done Agile before. A bunch of people looked at that, and they said, I'm out of here, because they just saw the death march starting. And so a bunch of people with critical business knowledge who had been around for years and years and years said, not going to happen. You're going to have to be honest with yourself and just decide, can I live with what we're doing? Can I be successful? Or at least can I be partially successful before it gets really bad? Because I think that demonolithing is, again, the whole premise of this talk is, it doesn't happen. And you just need to make sure that you understand what you're getting yourself into. So let's try and wrap this up. I had this slide before all the ChatGPT talk at the conference. Why can a monolith not be demonolith? Paragraph 3, while it is technically possible to demonolith an application, it can be time-consuming and expensive process, especially for large and complex application. It may be more practical to rebuild. So if ChatGPT agrees with my premise, I must be onto something. And again, I had this in here a month ago. I do think there's reasons to not demonolith and to actually start over. It's a hard argument. Takes some decent analysis. But let's take it from a product standpoint. When you demonolith, you're basically demonolithing in your functionalities like for like. I had this in the monolith, I have this in the demonolith. There's been very little forward motion on the features or functionality on the application. It gives you a time to re-envision what your application might do. You might look at some of your competitors and say, yeah, they're onto something there, what can we do? And that's really difficult in the monolith, and it's really difficult to demonolith. Now, I did say that technology, we can't do engineering for engineering's sake, but even this we can justify to leadership. I might need to change my tech stack. Maybe it's just going from Java to Kotlin, and I'm going from JEE to Spring Boot, whatever. It could be I'm going to Go, or who knows what. And that could be for the benefit of the organization. So you have an opportunity here to change your tech stack, not bring over a lot of the tech debt that you have, and potentially start over. And yes, I know that sounds expensive, but I think there are ways that can be mitigated. From a security standpoint, most applications that have been around for a while have had security bolted on or adapted little by little. Everyone will tell you you need to have security from the get-go. So it gives you an opportunity to actually address security, and I guess I would throw in compliance as well, right from the beginning. Demonolithing, much more difficult to do because, again, you've got the monolith sitting there doing what it's done forever and ever. This one's the difficult one. From a financial perspective, I think you can be better off. Now, 3 to 5 years? No. You've probably got duplicative teams. You have more expense than you want. But once you start moving your customers, especially in a software as a service model, to the new application, well, hopefully your infrastructure costs go down. Your maintenance costs go down. You're able to provide new features that the customers have been clamoring for. Financial is the most difficult one to deal with because, again, short term, it's going to suck. And right now, we know that the industry doing all sorts of layoffs. I get it. But demonolithing is probably more expensive. And with the right analysis going on these 4 tangents, I think you can come up with a compelling argument. At one place, I actually started doing that, soft selling, restarting it. I got a lot of people to say, yeah, I think you're right. It's difficult, but ultimately it's the way to go because too many places start demonolithing, fail, and there's 18 months, 24 months of effort down the tubes. Ultimately, this is not for the faint of heart. Whether you're going to demonolith your monolith or whether you're actually going to try and make an attempt to start over, it's not going to end the way you think. It's not easy. It's not going to be fun. But I think if you look at not demonolithing and instead go down the path of starting over, I think you might be better off. It might be that you take chunks of your monolith, because it might have evolved into logically 3 or 4 different apps. Maybe you just take out one of the logical apps and make that start over. Maybe that's a way to do it. But it's going to be hard no matter how you look at it. And that's it. There's my contact information if you care. And that's my slides in case you want to download them. Appreciate your time. I hope this was useful. Again, everyone will come away with something different, but I think this was fun. Thank you very much. So my cat heard the talk more than anybody else, and I never kept it under 50 minutes. So either I'm talking really fast or I've forgotten a bunch of stuff, because we got 5 minutes for Q&A. So I'll try and take questions if anybody has any. Or we can talk on the side if you're too embarrassed to admit what your organization is doing. That's fine too. No questions? Really appreciate it, guys. Have a good rest of conference.